Good morning. My name is James Little from Mass Spec Interpretation Services. Today I would like to share with you some new information about the Wiley KnowItAll software package that occurred in the 2024 version. In particular, process it for manual processing of EI GCMS data has been greatly improved in this 2024 version. The other parts of the software have remained pretty much unchanged, and you can find information on training concerning those on my website, A Little Mass Spec and Sailing. The improvements that were noted in this version of 2024 are compared versus the previous 2023 version of Process It. In particular, major peaks are automatically selected when the file is opened. When the user selects the peak of interest, 1.3 million EI library spectra are searched very quickly when the peak is selected. Duplicates and replicates are removed from the results hit list. The results are displayed directly in Process It as opposed to when it was previously sent to maybe mine it or search it to get the search results. An intuitive bar interface is employed for selected ion chromatograms, and the same type of interface is utilized by the user for manually obtaining background subtracted spectra. There's also some nice area determination software present within the application. In this handout that's associated with this presentation, I have a lot of additional information about where to find the files, the types of setup, etc. But I'll go through those, but I just want you to realize you might be useful to go back and look at the handout if you want to set up some of these settings yourself. Now let's take a look at the new software. The first thing we need to do is find an example file. And it's somewhat hard for me initially to find that, but I'll show you the tree that you get to it. So if you click on MS Expert, you'll see it's down several levels into the software, and that level is also shown in my handout. But we'll pick in MS Expert, that's where the example files are. You'll notice as you go through the files, you can see them in the bottom window here. So let's go pick the one I want. I want the O-band file, so I'll pick it. You can see it in the bottom, and let's just say open. It'll go through all the processing, but before we talk about that and the results, I want to show you the setup. So it's very important that you get the view set right, and there's a lot of different options for this, but here's the ones that I like, and I think a lot of them are set up as the standard view, but they might not be all of them. So if you're missing something, be sure to go to my handout or look here and make sure your selections are the same as mine. Go over to the File and go to Settings. We need to make sure the right libraries are searched and properly searched. I think these are the standard settings, so I'll leave those alone, but for your record you can see them here. And what I usually pick is Search All License Reference Databases. And in my case, with the ones that I have on my system, there's over 1.3 million library spectra to search. And select that and say Apply. Mine's already been applied, so I'll just say OK. So now you're pretty much ready to run the file. So let's repeat part of that process just to show the file processing and the library search results. So I'll go back and open the file again, open the data file. I'll go find the same one that we had before and say open. You can see immediately when you tell the system to open the file, it puts little boxes above the top of every peak to show you where the center of the peak is. And that just makes it easy to decide which component you're looking at. And when you click on this box here, let's click on this one, what happens is that the computer goes and does a library search of that component. And you'll see over in the bottom, you can see that it's octanoic ethyl ester. You can see its structure at the top. You can also click down and see the second best hit, which will show you the reference spectrum and also the unknowns library or unknown spectrum. In the bottom window here is a butterfly display. And you can just go through and using the mouse, click on the different boxes and see your results. And if you decide you just want to do one manually, let's say we want to look at the tail of this peak to see if it changed over the top, which is ethanol. We just click here on the bottom and the system automatically gets the spectrum and does the library search. So you can see it searched about 1.3 million compounds almost instantaneously. The library search is so fast, so it's just very easy to look at anything that you desire to in this manner. So now let's talk about selected ion chromatograms. They've changed how that is performed in the system. It's very easy to do now. So in this case, they've added bars. So if you wanted to see, let's say if we look at the spectrum of this peak here and we see it has an ion at 88, we'd like to see where other components have that ion at 88 also. We go to the bottom where we see this bar. You can see that the mouse has changed its form there to show that you can spread and get a bracket there. And you go over to 88 and you select it. And let's make it so it's easier to see. I'm going up here and changing the display to a different mode so I can get a better view of it. There's a lot of different ways you can look at the display, so I'd encourage you to try some yourself. These are my two favorites here. And you can see now that we can see where mass to charge 88 occurred versus time. And this 88 is somewhat important for this class of compounds because if you look at the structure over here on the right, that's a rearrangement where you get CH3, transfer of a proton, CO, O, ethyl. And that's characteristic of ethyl esters. So you can see there's 1, 2, 3, 4, 5, 6 likely ethyl esters in this particular sample. So you can see that's very easy to do now. The other thing is you can go over to the display here and decide if you didn't want to display the TIC, you can remove it or you can put it back in. If you decide you don't want that, you can take it out or put it back. But the other thing you can do is you can also go down here and put the value 88 in, and it'll do the same thing if you wanted just to specify an ion as opposed to picking it with the bars at the bottom. And so it's very flexible in that regard, so it's easy to do the displays here. And then if you want to get rid of them, you can get rid of things that way, or you can go to the bottom here and get rid of the 88 by going to this little trash can on the side is another way to clean up. So there's several different ways to run the program depending on what you desire. So now let's talk about background subtraction. When you bring the peaks into the program and select here, let's say, these are not background corrected for maybe chemical noise here or air or electronic noise, but in most cases it doesn't matter. You can do them without doing the correction. However, if you want to do very small peaks, let's say we wanted to look at 25 through 26 minute range and pick up these two little peaks here, you might need to do a background subtract. And we do that manually using bars that are very similar to the bar that was used for the selected ion chromatogram, except they're the two that are located above and below the chromatogram here. So let's expand here. To do that, there's different tools, like selection mode is what we're normally in when we're working on things. So you need to realize you need to switch back and forth by right-clicking. So if we want to go to horizontal zoom mode, we can go and zoom here, and we get the nice display of the two small peaks. The way I've got these set here, again, you can change these to make them full scale or how they're displayed here. This is my favorite display. So we've got that done now. Let's just, while we remember, let's go back to selection mode for processing. And we'll go here. You can see again the average range bar. When you go in it changes. If you have the crosshairs, it nicely shows you where it will be taking the spectra. So we go down here, and we're in the average bar, range bar. We pull across to get the average of the spectrum. And you can see it already calculated that it thinks this is hexadecanoic acid. But let's correct for a little bit of background noise. So if you go to the top, we have our background range bar. Let's take a range in front and a range in back. And every time you do it, it redoes the search. It's so fast. And again, it shows that it's hexadecanoic acid. So this is very easy to do to get this. And if you want to clean these up, you can easily use the trash can, let's say, to get rid of the background. Or if you want to get rid of both of them, you click that, the trash can at the bottom. Now we're back ready to start again. Now we can go, if we want to do this other peak, we'll go and get the average across it. We'll get some background here and here. And you can see in this case it's undecanoic acid. It's got a site of unsaturation. The other thing you can do with these bars, you can move them around. So if you come down here and you're within the bar that you already have, You can move it around if you want to get it better centered. If you decide you're a little bit too narrow, you can grab the edge of it, expand it a little bit on both sides. Again, it's just doing the searches so fast that it looks like they're done instantaneously, but it's just a very fast search of this 1.3 million compound library that I'm searching, or a collection of libraries. And you can do the same things for your background range up here to move them around or change the range that you use. So it's easy to do these background subtractions, and like I say, in most cases for the big peaks you don't need to do this, but for the smaller peaks it's very good if you're adding something to the library to get a very good quality spectrum to do a manual background subtraction. I want to remind you the differences between the two processing programs. If you look in the left corner up here, we have Process It, which we've been doing manual type analyses, but we also have MS Expert that automatically corrects for background, library searches everything, and even deconvolutes overlapping peaks. So let's go and open a file in MS Expert. Well, let's first look at it and process it, then we'll go to MS Expert. So we'll go File, Open Data File. We'll come down and find this V50, which is a relatively complex mixture. We'll open it. You can see at the bottom now that I have both files there. If you look at the tabs here, you can go back and forth between files so you don't lose those. Let's blow it up a little bit. So I'm going to horizontal mode to expand the range here. I'll go back to select, so just remember to go back to selection mode when you get through. You can see these peaks here are a mixture of things, and it didn't really probably figure out what this one is. So if you wanted to use that, you could probably background subtract here, here, and take the foreground here, background here. You can figure out what it is, but sometimes for complex mixtures, it's better to go to MS Expert. So let's do that. We'll open the MS Expert program, and I already had it open here. Let me just close it so I can run it for you. So File, Open Data File. We'll go down and open V50 in the MS Expert. Say Open. And I pause for a second because the voice tends to break up when we're trying to do these because it's doing so many things within processing the data. But you can see what has happened is it went through and labeled all of the peaks here, background subtracted for each one of them, and just like Process It, you can click and see the results, but instead the results are up here on the right. You can see in this case they're not calculated. The library searches of this 1.3 million compound for each component are not done manually or instantaneously when you select them, but it does it for the whole file, so it takes a little bit longer to process things this way. You can see it's identified all of these, so if you click on this, you can see that that peak at this point in time, around 7 minutes, is methylene chloride. So you have the structure here, you have comparisons below of the library spectra and the unknown, and you can look here by expanding and see the other unknowns. And I have another section that talks totally about MS Expert, which you might want to refer to for this program, but I just really wanted to contrast the two programs. So here if you go to zoom mode, horizontal zoom mode, and look here, you can see there's probably 1, 2, 3, 4 components in here that have been deconvoluted, and you can step through them and look at them and get the pure spectra in this manner. So it just depends on the type of file you're doing and what you want to do, whether you use manual or you use MS Expert, but both of them are very powerful tools for processing your EI GCMS data. So the last thing I'd like to share and process it, the 2024 version, is the area calculations, which is very nicely done. If you come up here and say Process, I believe, or Edit, View, Analysis, Peak, Area, Integration. If you pull that down, you'll get a menu here, and you can pick the type of integration method you want, and then just say Automatic Integration. Say Replace. So it populates the table for you. You can see all the areas have been nicely calculated here and displayed in this table. You can also get rid of things if you don't want, like that peak out there due to a baseline rise at 34 minutes. Let's just make that one go away. So let's delete that row. And now we have them all calculated and displayed. So if you want to go and edit or export them, you can go to File, you can say Export Peak Areas, and that throws them into an Excel spreadsheet where you can use them to compare relative concentrations, assuming that they all have the same response factor. So that's very useful for giving customers reports at times. So I hope you found this video useful, and use it with the many other training videos I have for the other parts of the programs that you can find on my website, A Little Math, Spec, and Sailing. Good day.